Hello and welcome to this edition of Stats Chats. We are going to roll up our sleeves and talk a little bit about preparing to analyze nonparametric statistics. Nonparametric statistics are a whole new world when compared to parametric statistics. They do not require the same assumptions of normality that parametric statistics require. So oftentimes they're considered the researcher's plan B. However, they're not totally assumption free. They do require a few assumptions, and that is random samples and independent observations. Now, you can still conduct a nonparametric analysis with non-random samples, but that would then need to be listed as a limitation of the analyses and the study findings. Some statisticians claim you need random samples for ANOVAs, but many people still use ANOVAs when there's not a random sample, but list this as a limitation. I was talking with a colleague who's a statistician named Tiberio, and he's worked on a lot of grants, and he was saying he's found that this is often the case. With multiple t-tests, though, if we do, let's say, more than one t-test, with parametric statistics, we would have to do a Bonferroni correction. So we would take our p-value or alpha level and then divide that by the number of analysis conducted, and we get a new p-value. So if our p-value was set to 0.05, which it often is in the social sciences, and then we ran three t-tests, we divide that 0.05 by 3 and get a new p-value for our significance level. Sometimes statisticians prefer to do an ANOVA rather than multiple t-tests to help reduce that error rate. So we'll talk about the non-parametric alternatives to ANOVAs and t-tests. But there's several decisions we have to make when we're analyzing data, right? How do we analyze the data? Practical application, in terms of, a lot of times when stats students get the data, it's all cleaned up and ready for analysis. But in real research, we have to spend a lot of time preparing the data for analysis. Another thing to consider is statistical decisions and data organization. How do we organize our data based on the type of statistical decisions we're wanting to make? So we're going to talk about one example of a test that is similar to a paired samples t-test, but it's a non-parametric alternative called the Wilcoxon-signed ranks test. And so here, we'll typically use this when the data is not normally distributed. So how do we find out if our data is normally distributed? Well, we can conduct a descriptive statistics analysis, and we can look for skewness and kurtosis, and we typically look for a value that is greater than plus or minus 2 in terms of skewness and kurtosis. Okay, so for the Wilcoxon-signed ranks test, it is, again, similar to the paired t-test in parametric terms. And it examines repeated measures. So if you have a pre-test and a post-test, and you have data that is not normally distributed, the Wilcoxon-signed rank test may be the best tool in your toolkit to use. So anytime there's a time 1 and a time 2, or a condition 1 and condition 2, this may be helpful. It does need one continuous variable, and we can find this test in SPSS, and let me just show you what that looks like. If you go to Analyze, and then once you click on Analyze, a drop-down menu will appear. You can scroll down to nonparametric test, and then when you mouse over nonparametric test, another drop-down menu appears, and then if you scroll down to the last option, legacy dialogues, another menu appears, and this is where you can select your statistical test. So if we're looking at two related samples, like a pre-test and a post-test, we can click two related samples, and then this dialog box appears. And for the Wilcoxon, we select Wilcoxon here, and then we will put in our variables. So for here, we're looking at post-test well-being and pre-test well-being, and we can select options and then click OK. And then SPSS will conduct the analyses for us. and provide us with that output. So again, just to review, we go to analyze. Oh, excuse me. So that's how you do the Wilcoxon signed ranks test. But in order to determine if this test is maybe the best fit for your data, you might want to look for skewness and kurtosis, see if the data is normally distributed. So we have a data test from a workshop that was conducted on a group of behavioral sciences students. So we go to analyze, descriptive, and skewness and kurtosis to look at the descriptive statistics. So oftentimes moderately conservative researchers do use this rule of thumb to say if the data is not more than plus or minus 2 in terms of skewness and kurtosis, we can conclude that it's pretty much normally distributed and use parametric statistics. So this is the output from a descriptive statistic analysis for the data set that our research team is using. Make this a little bit larger because it's hard to see there. But if you look at skewness and you look at kurtosis, so that would be the second column to the end and the fourth column from the end. If you kind of scroll down with your eyes and look for anything greater than plus or minus 2, we can see that the pre-test trait emotional intelligence well-being was 2.8. So at the time of the pre-test, the levels of well-being of the students was not normally distributed. And you might be wondering, well, what is well-being? So let me move on from slide 10 down to a later slide I have in my slide deck, just to give you a visual of well-being from an article by Petrides, who developed the Trait Emotional Intelligence Questionnaire. This is from his article. And you can see that trait emotional intelligence is divided into these 15 traits, and then each trait is assigned a factor, except for self-motivation and adaptability. So well-being includes 3 factors: trait happiness, optimism, and self-esteem. So we're looking at happiness, optimism, and self-esteem when it comes to looking at well-being. So let's keep that in mind and go back up to slide number 10 here. So that trait is and happiness, that sense of well-being, was not normally distributed. Let's see what else. There is also a measure on another assessment of suffering, and a measure, the trait emotional intelligence measure of self-control at the time of the post-test, was also not normally distributed. So let's go back down to that diagram and look at self-control. Now, self-control is emotion regulation, low levels of impulsivity, and stress management. Now, one thing that we have to think about that can be a confounding variable is that the last week of the semester for this workshop it coincided with the exam week. And so, as you can imagine, stress management and emotion regulation can be more challenging for students during exam week, the week of final exams, last week of the term. So that's something we want to keep in mind. Okay, so going back up to that previous slide, there we see, okay, those are the 3 values that we could say are pretty much not going to be normally distributed. Sorry about that, my doggies are not wanting to share their pillow. So when it comes to that, we might want to look at how is this data distributed. So for example, we might want to look at a visual of what this looks like. We know what's not normally distributed, but we may want more information. Then we can go and do a histogram. So in order to create a histogram, we can go to SPSS, and we can go to graphs and then mouse over legacy dialog. A new drop-down menu appears, and then we can click on histogram, and then we can select the variable we'd like to look at there. Now, I like to check right here, display normal curve, because then you get the visual of the normal bell curve superimposed over your data, and it can just help to get an idea of whether that data is normally distributed. Okay, so you can see where we went in and selected those options. Now, one thing you can do is use the syntax to do this, so you don't have to go in and do it each time. So if you use the syntax, There, you click paste on this right down here on the left under histogram, and it will bring you into this menu for the syntax editor, and you can copy and paste this, and you can change the variable name. And so you can see here where I added self-control and well-being. Now, I don't see normal in here, so that means that we did not select the box for the normal curve in this previous slide. See where it says display normal curve? We really need to check that box if we want to see the normal curve. So then you can go back when you check the box, then you'll see normal in red here. And so we just update this for each one, and then that's going to run all 3 histograms. And so then this was the SPSS output for the pretest emotional intelligence well-being. You can see that the data is negatively skewed. Remember, the tail tells the tail. So the tail of the distribution is sort of stretched out a little bit further to the left, to the negative end. If you imagine the number line right in the middle, data to the right is positive, to the left is negative. So, I don't know if you guys have heard of the rapping mathematician, but he made up a dance called the number line dance and a rap. And when I was working with students on math anxiety groups, we actually did a little dance to this, choreographed by Zhenya Klukin, but it said something like negative to the left, positive to the right. It's a number line dance, and I could dance all night. So these, when the tail stretches out to the left, remember negative to the left, that's a negative skew. The tail tells the tail. So both of these look to be slightly negatively skewed. The second one looks to be more leptokurtic. You can imagine the peak of the curve sort of leaping upward. As you can see, number of values of 6 there at the top of that scale. And then the last one that was not normally distributed was post-test self-control. Again, the last week of the semester, self-control such as stress management, emotion regulation was negatively skewed. So we have some lower values stretching out the tail here of this distribution of data. So we might say, okay, well, since this data is not normally distributed, right? If it was normally distributed, the mean, median, and mode would be the same. The peak would be right in the middle. If we printed these out, we could fold each distribution in half. They'd be exactly symmetrical on both sides. You can see that they're not. So here we might decide, okay, well, let's take one of these, either well-being, suffering, or trait emotional intelligence, self-control factor, and analyze those using nonparametric statistics. So those are the values that we're probably going to use nonparametric statistics with, and the rest of the data we can use parametric statistics. So now we're set up to look at pre-test, post-test on well-being using a nonparametric assessment called the Wilcoxon-Signed Ranks test that will allow us to compare pre-test, post-test, or repeated measures in a non-parametric way. All right, so these are some thoughts about how to set up your data, how to think about, looking at your data, checking out the skewness and kurtosis using descriptive statistics, seeing what's more than plus or minus 2, generating histograms, look at what that data looks like, and then deciding what you'd like to analyze with nonparametric statistics. In a future tutorial, we'll look at how to set up a Wilcoxon-Signed Ranks test and conduct a nonparametric analysis comparing the mean from a pre-test to the mean of a post-test. Thank you for taking the time to watch this tutorial, and I hope this gives you some concepts to contemplate. Until next time, God bless you.